This is item 4 in the activity. So we have C6H5NH2 plus H2O forming C6H5NH3 plus OH minus. Here, the equilibrium constant is 3.8 times 10 to the power of negative 10. We also have the initial concentration of this species or this chemical species is equal to 0.26 molar. We're asked to calculate the concentrations of all the species present in the solution. So before we do the uh, expression, let us first create an ice table. Again, that's initial, change, and then equilibrium. So here the reaction here is C6H5NH2 plus H2O, C6H5NH3 plus OH minus. So here we have this one is the initial concentration of this one, so it's equal to 0.26 molar. And then here we're asked to determine the other parts of the table. So of course at the start of the reaction we don't have any of the products, so we have zero products here or zero concentration of the products over time. So here we have a decrease on the concentration of the reactant. Let's call that one as X. So here, since it's decreasing, I'll put here negative X. And of course, over time, these reactants are turning into the products. I'll call it as X also. Then on this case, we have plus X. And the same thing for this one is also plus X. So in this case, this is 1x obviously because here it's based on the coefficient on the balanced chemical equation. So they have the same number of moles on this reaction. And of course, the equilibrium concentration it's equal to the initial concentration plus the change in concentration. So this would be 0.26 molar minus x. Then this one 0 plus x is x, 0 plus x is x. Okay, so note that we have skipped H2O because as you see here, H2O is liquid, and again, we don't include H2O in the expression. So again, this one is liquid, so we don't include this one also in the ice table. Okay, so after this one, okay, so we are finding for the X here. So let's note that our KEQ is very small. That's a very small number. It's equal to 0.00000000038. So this is equal to 3.8 times 10 to the power of negative 10. So when KEQ is very small, it means that this reaction favors the reverse reaction. So in this case, there will be a very small changes on the concentration of our reactant on this case. So here X will be very small also. So it's probably equal to 0. So on this case, we'll assume that X is equal to 0. Therefore, 0.26 minus 0 is approximately, okay, it's approximately equal to 0.26. And then from here, we can use the equilibrium constant expression. So let's write the equilibrium constant expression for this reaction. Okay, so that's equal to, okay, the equilibrium constant is equal to the the concentration of our products. We have C6H5 and H3 plus times the molar concentration of OH minus over the molar concentration of this one, of this reactant. We have the molar concentration of C6H5 and H2. Note that H2O is liquid, so again, we don't include pure liquids and solids in our expression. Now, we are going to substitute what we have here. So we have KEQ, that's equal to 3.8 times 10 to the power of negative 10. 3.8 times 10 to the power of negative 10 is equal to, so here the concentration of the products, of course we have X and then X, so we have here X times X, so this one is X, diba? Then this one is also X, over, we have the concentration of our reactant, which is about 0.26. So this one is about 0.26. I'm going to use the space here, so just follow the sequence here. So of course, x times x is equal to x squared. So let's copy first this one. Times 10 to the power of negative 10 is equal to x squared over 0.26. Since we are finding for the x, so we cross multiply this one. So that's 1 times x squared. It's obviously x squared is equal to 3.8 times 10 to the power of negative 10 times this one, 0.26. And so let's multiply this one. Let's use our calculator. So that is again 3.8 times 10 to the power of negative 10. Negative 10. Again, sorry, we have 3.8 times 10 to the power of negative 10 times 0.26. This is 0.26. That's equal to 9.88 times 10 to the power of negative 11. Let's make it 9.9. Okay, 9.9 times 10 to the power of negative 11. So that's negative 11. Since we are finding here for x, we find the square root of both sides. Of course, this will be cancelled. So what's left is x. Then we have the square root of this number. What's the square root of this number? It's equal to 9.94. So this one is 9.34. So here x is equal to 9.34. So therefore, on this case, our concentration of C6H5NH3 is equal to 9.34. The same thing with this one is also 9.34, and for this one is equal to 0.26.